Alright guys, so at this point in the course, we should already be familiar with how neural networks work and how to implement them in Keras, but today we are going to be working with a slightly more complex neural network, and that is a convolutional neural network. And convolutional neural networks are especially helpful when we're working with any type of image recognition. And this is because, unlike a traditional neural network, where it's going to feed the network one pixel at a time, a convolutional neural network is going to feed the neural network in convolutions, which is a chunk of the image. So for instance, a traditional neural network would be one pixel at a time. A convolutional neural network is going to say this part of the image, then this part of the image, then this part of the image. And the idea behind this is that because the neural network is being fed in chunks, it's going to pick up on certain patterns in the data that it can't pick up when it's only being fed through one pixel at a time. So one chunk might have a certain edge or line that's going to help the neural network decide what it is. And so this is why convolutional neural networks are extremely helpful when we're working with image recognition. But that's enough about basic convolutional neural networks. Let's talk a little bit about the data set. So the data set that we are going to be using is called MNIST, and this is a data set so famous that it's already in Keras. So all we have to do is say import Keras and then MNIST equals keras.datasets.mnist, and our data is in Colab. So that's really cool. Basically what MNIST is it's a collection of handwritten digits and then their corresponding Y value, which is what the digit actually is. So we are going to train a neural network to be able to take an image in and then tell you what number that image is. So without further ado, let's get started. So we already have Keras imported. Next, what we're going to do is we're going to set the X train, the Y train, the X test, and the Y test. So basically, 60,000 images are going to be for the training, and then 10,000 images are going to be what we set our model on, what we test our model on. So in order to do that, all we're going to say is X underscore train, comma, Y underscore train. Then we're going to say comma, X underscore test, comma, Y underscore test. And that is going to be equal to MNIST.load data. So this should load MNIST into Colab. We'll give it a shift enter. Alright, it looks like everything's working fine there. Next, what we're going to do is just to sort of show you what the data looks like, I'm going to import matplotlib.pyplot as plt, and then I'm going to print out the first image in our data set. So we'll say plt.imshow x train 0 plt.show, and then I will also print out to Colab the corresponding Y value with that. So we'll say Y train 0. So we'll print this out, and here you see we have a 28 by 28 image, and you can see it's clearly a handwritten 5, and then its corresponding Y value right here is 5. Alright, so that looks good. Next, what we're going to do is we're going to break down the data so that the neural network can digest it easier. So we are going to take this 28 by 28 image and make it as simple as possible so that the neural network can not waste too much computing power on little things and just focus on trying to identify the image. So this will save us some time and also save us some error. It's going to make our model more accurate. So the first thing that we want to do is we want to reshape all of the images. So we'll just say X underscore train is equal to X underscore train dot reshape. And if we press tab here, we see we need the shape, which is just going to be X underscore train dot shape 0. And then we're going to say 28 by 28 by 1. So 28 being the height of the image, then the width of the image, then 1 being the Z value or the thickness of the image. And because we're only working with two-dimensional images here, we're just going to say it's equal to 1 pixel. Now the cool thing is in Keras you can actually work with three-dimensional images, but we're not going to be doing that today. So, and whenever you're working with one-dimensional images, just remember to keep this at 1. And then let's do the same thing for X test. So I'm going to copy this line here and then paste it here. So X test will also have a different shape. X test that shape. And then finally, let's set the input shape. So this is going to be the shape that we're inputting into the neural network. And if you can guess what this shape is going to be, it is 28 by 28 by 1, which is the size of our image, of course. Finally, what we want to do is we want to normalize the image values. So right now, each pixel is on a value of 0 to 255, with 0 being purple and then 5 being the brightest yellow here. So this is kind of unnecessary for our neural network to be thinking between 0 and 255. Instead, what we're going to have is we're going to have the neural network being imported values from 0 to 1. So we're going to normalize the data set. And this is pretty common within machine learning. And all we have to do for it is just say x underscore train equals x underscore train dot as type. Make sure that it's a float 32. We don't need 64-bit. And then we'll say x underscore train slash equals to 255. And basically what this means is slash equals is the same thing as plus equals, except for you're dividing instead of adding. So all we're doing here is just converting the x train to float 32 and then dividing it by 255 so that every value is out of 1. So we've done that for x train. Now let's do that for x test. So I'll copy these two lines, paste them below, and we'll say x test is equal to x test dot as type float 32 x test slash equals 255. All right, we'll run that cell, and it looks like everything is going good. So next what we're going to do is we are going to convert the y values into ones and zeros, making them categorical variables. So this is called one-hot encoding, and without it, the neural network might categorize numbers based on how they are related numerically rather than how they look. So basically, because we can only have digits from 0 to 9, there is no 0.5, there are no fractions. Because of that, we have categorical variables. So it's either a 4 or a 5. It's either a number between 0 through 9. It can't be anything else. And because of that, what we have to do is we have to one-hot encode our y values. So this might seem a little bit complex the way that I'm saying it, but hopefully when you see it in code, you'll get a better understanding of what I'm talking about. Basically, what I'm going to do to show you how it works is I'm going to print y train 0. So I'm going to print the first y train value. And then I'm going to say y train is equal to keras.utils.to underscore categorical. And then we'll say y train and then 10, because there are 10 possible classes, which are the digits 0 through 9. We'll do the same thing with y test. So I'll just copy this line, paste it here, say y test. Okay, that looks good. And now that we've gone to categorical, now that we've one-hot encoded our y values, I'm going to print y train 0 again. So let's run that. And you see our first y train by default is 5. And now it is this array with a bunch of zeros and 1, 1. So essentially what we did is right here it says 5. What we're saying now is that it's not 0, which is why we have a 0 here. It's not 1, which is why there's a 0. It's not 2. It's not 3. It's not 4. It is 5, so this value is going to be equal to 1 instead of 0. And it's not 6. It's not 7. It's not 8. It's not 9. So when we run the model, what it's going to do is it's going to perform an array, and it's going to say, okay, we are 10% sure it's a 0, we're 0% sure it's a 1, etc., etc. We're 95% sure it's a 5, and then it's going to say, okay, if we're 95% sure it's a 5, and none of these other values are even close to that number, we're going to say that this number is a 5. So that's basically what we want our model to sort of figure out, and that's why we use one-hot encoding. Otherwise, it might think, okay, we think it's maybe a 4, we also think it's maybe a 3, so then we're going to take the average of both of those and say that it's a 3.5. And that's not how we want our model to think. We want our model to think categorically, which is why we use one-hot encoding. Alright, so now it's time to actually build the model, and bear with me because we're going to be working with a lot of new layers that we haven't worked with before, and I'll try my best to explain what each of them does, but if you want to get more in-depth research of what they're actually doing mathematically, I have some links in the description for that. So basically, the first thing that we're going to do is create our model, so we're going to say model is equal to keras.models.sequential. Next, we are going to have our input layer, and our input layer will be a convolutional layer. So we'll say model.add keras.layers.conv2d, because remember we can also do 3D convolutions in Keras, but we're sticking to 2D. conv2d, and then inside of here we'll have 32 neurons. Our kernel size will be equal to 3 by 3. And basically what kernel size is if you remember to the beginning of this video when I was talking about how convolutional neural networks, they take a chunk of the image at a time and feed that into the neural network. Our kernel size is the size of the chunks basically, which is going to be 3 by 3 pixels. And again, you can adjust these values how you want. I got this part of this code off of the Keras website, so this is supposed to be one of the more accurate ways to do this. Next, we're going to set our activation function, which is going to be ReLU. And we are also going to set our input shape equal to input shape, which is the variable that you see we set up here, 28 by 28 by 1. Alright, so that's our input layer, all nice and done for us. Next, what we're going to do is we're going to add another convolutional layer. So we'll say model.add keras.layers.conv2d. This one we'll say has 64 neurons, so twice as many neurons. The kernel size will be the same, which is 3 by 3. And we'll also set the activation equal to ReLU. So ReLU will be our activation function for that. Now what we're going to do is we're going to make a max pooling layer. And to put it simply, what max pooling is going to do is going to take a section of our image, and it's only going to display, it's going to turn 4 pixels, 2 by 2 pixels, into just 1 pixel by taking the max pixel of that image. And you can set it, it doesn't have to be 2 by 2, it can be 3 by 3, but in this example we're going to set it equal to 2 by 2. So basically, because it's setting every 4 pixels to just 1 pixel, we're decreasing our image by a fourth, but we're also still maintaining the features because it's only taking the max value, which theoretically would be the most interesting pixel because it's the pixel that's the most different. So we'll say model.add keras.layers.max pooling 2D, and we'll set the pool size equal to 2 by 2 because we want every 4 pixels to become only 1 pixel. Alright, so that looks good. Next, what we're going to do is we're going to create a dropout layer. And basically what a dropout layer is going to do is, because we have so many neurons, we have 32 neurons in our first layer and 64 in our second, because we have so many, there's a good probability that some of those neurons just aren't going to be helping our model. They're going to take extra computational time, and they can even be hurting our accuracy. And so to prevent that, what we do is we create a dropout layer, which is basically going to randomly select a neuron and then just stop using that neuron and then find out which neurons are actually working the best. So this helps simplify our model a little bit. So we'll say model.add keras.layers dot dropout, and we're going to say the probability of a layer getting dropped out at this point is going to be 0.25 or 25%. Next, we're going to flatten the image, and to do that, we're going to say model.add keras.layers.flatten. And if you see right here in our image, we have some pixel values that are kind of greenish or blue instead of just being purple or yellow. And all flattening is going to do is it's going to make this as extreme as possible. So basically either make that value 1 or 0. Or before we ran this cell, it would be 0 or 255. Okay, so now that we have our image flattened with a flattening layer, we are going to add another dense layer just for fun. So we'll say model.add keras.layers.dense. We'll set it with 128 neurons, and the activation will be equal to ReLU. Again, we'll be using rectified linear units. Finally, we're going to add another dropout layer. So model.add keras.layers.dropout, and we'll set that probability equal to 0.5 because 128 neurons is quite a bit, and there's a good probability that a lot of those neurons won't be helping our model. Finally, we are going to add the output layer. So we're going to say model.add keras.layers.dense, and we are going to set the dense layer equal to the number of classes, which is 10, any digit between 0 and 9, and the activation this time is going to be the softmax function. Alright, so let's run that and see how it works. It looks like everything's fine with our model. So finally, it's time to get training. So we're going to say model.compile, and we are going to compile the loss function is going to equal to keras.losses.categorical cross entropy, because again, this is a categorical problem. And the optimizer, instead of using atom, we're going to use another one called adagrad. Optimizer is going to be keras.optimizers.ada delta, and we'll do that just for fun. And then again, the metrics that we are trying to measure for is going to be accuracy. Alright, finally it's time to train our model, so we're going to say model.fit xtrain to ytrain. We'll just set the batch size equal to 128. We'll set the epochs equal to 20, and our validation for this will be equal to validation data for this will be equal to the X test and the Y test. Okay, so I'm going to run that now, and I'm going to speed up the video so that you guys won't have to wait for that, and I'll see you then. Okay, so it looks like our model's done training. It also looks like we should have done early stopping because there isn't that much improvement, especially in the last epochs. But again, on MNIST dataset, you want to make it as accurate as possible because you could be potentially feeding a lot of numbers through it, and you want to make sure that you have as little errors as possible. But I hope you guys enjoyed your break. I walked my dog, ate lunch, had a good time. It took me on the Colab GPU about 30 or 40 minutes for this to train, so that's cool. But now it's time to finally print the accuracy of our model. And it looks like right now it says it's about at 99.2%, which is pretty good. But let's just run it again on the test data. So we're going to print model.evaluate x test y test, and we're going to print that out. It's going to train on all the, it's going to run on all the testing samples, which we have 10,000 of. And you see right here, this first number is the loss, and the second number is the accuracy out of 1. So we see that our total accuracy is 99.2%. So congratulations, guys. You officially created a convolutional neural network in Keras. Thank you so much for watching, and I'll see you in the next one. Thank you guys so much for making it to the end of this video. As always, if you enjoyed it, make sure to hit that like button. Also, if you have any questions, comments, or concerns about what we did in this video, please leave them down below. Now, if I could have just one more minute of your time, I would like to tell you about a service that I've been using for over a year now called Scribd. Now, just as a side note, Scribd did not sponsor me to make this video. I just wanted to tell you about it. Put simply, Scribd is a lot like Audible, except for instead of being $15 a month, it's only $9, and instead of only having 2 audiobooks per month, you get an unlimited access to a plethora of audiobooks, ebooks, documents, and even sheet music and magazines. So for me, this was obviously a no-brainer, and right now, if you use the link in the description, you get 60 days free of Scribd, and I get 1 month if you sign up using my link. So that's why Scribd didn't officially sponsor this video. I'm just telling you about it so that I can get some free months, and I can continue learning, and you can also continue learning with your 60-day free trial. So thank you guys so much for making it to the end of this video, and I'll see you in the next one. Peace.